we have been drawing Lewis structures for a while now, and you're probably familiar with all atoms need to be octet, so 8 can go over, right, or can go under, right? And but some atoms can be over octet, right? Depends on what orbitals are in it. All right, let's take a look at the first period atoms. So we have hydrogen and helium. These two got only an s orbital, so which means that these two can hold up to only 2 electrons. Right, in a valence electron on a valence shell. In second period, right, row number 2, we got carbon, oxygen, nitrogen, fluorine. These 4 got 1 s orbital and 3 p orbitals. So the maximum number of valence electrons they can hold is 8. Can't go over that. But if you go to the third row, fourth row, or anything beyond, they start having d orbital, d and f, d, f, g. This guy can hold more than 8 electrons. Okay, give you some examples. So SF6, sulfur is totally over octet. Right, so sulfur is in the middle, fluorine is around it. So Lewis symbol, so 2 unpair, so group 6, 2 unpair, fluorine group 7, so 1 unpair. Each fluorine have to be octet first, so they need 1 electron each, so you get this structure. Okay, sulfur is totally over octet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, right? But sulfur can hold it because the extra electron will go to a d orbital, and he's fine. All right. Draw Lewis structure of sulfur dioxide. How many resonance structures are there? Identify the most important resonance structures. Okay. All right. So stop. Pause the video. I'll try on your own. Maybe take you maybe 2, let's say 5 minutes. Just give your time. 5 minutes. Right? No rush at all. Get a few resonance structures. All right. Let's check with me. So sulfur dioxide looks like this. All right. So sulfur is in the middle. Oxygen is around sulfur. All right, Lewis structure. So you got that now. All right. So makes oxygen octet first. So 2 bonds, 2 bonds. Get that structure. All right. Now, if you count the check the valence electron of each atom. So oxygen on the left side, 1, 2, 3, 4, 5, 6, 7, 8, 8 atoms. Oxygen on the right, same thing. So octet. Sulfur in the middle, though, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 electrons. Right. So in this case, normally we will have to remove so 10 electrons. So if you want to go to 8, so we have to remove 2 electrons or 1 bond. So you can do on the left side or do on the right side. Right. So basically, and sulfur, but sulfur is on a third row. So sulfur have a d orbital, which means that sulfur can be over octet. So we count this structure too. So ultimately, sulfur dioxide have 3 resonance structures. Okay. Now, which one? Okay. Now, which one is the most important structure? So we have to check it. All right. Start with the oxygen on the left side. All right. Let's do the formal charge. All right. So the minimized formal charge, that's the best structure. All right. Oxygen group 6. 6 dot, 1 line, total of -1. Sulfur in the middle, so group 6, same thing, all right below oxygen. 2 dots, 3 line, +1. Double bond oxygen, so 6, 4 dots, 2 lines, 0. Okay, so the double bonded oxygen is 0 basically, right? So this guy right here, 0. Sulfur in the middle, right here, so we have 2 double bonded sulfur. So group 6. 2 dots, 4 lines, total of 0. Okay, double bonded oxygen also 0. Right. Now this guy right here is similar to the structure on the left side. So double bonds oxygen, that's also 0. Sulfur in the middle, so 3 bonded. So 3 bonded sulfur is +1. This guy is +1. And the oxygen here, single bonded oxygen is -1. So that's -1. Who is the most important structure? In the middle. So the real sulfur dioxide will look more like this guy, right? And the other two contribute to the real structure just a little. Okay. All right. Chapter 9, class activity number 2. So more Lewis structure, draw the whole thing. All right. I want to see how you draw it and calculate the formal charge A, B, and C. All right.